Hey guys, it's Mr. Ellis, and I'm going to show you a couple example problems with zero launch angle projectiles. And these are objects that are launched with a straight horizontal velocity off some sort of tower or cliff. And we've talked about some assumptions that we can make to help us solve these. So here's the problem about Victoria Falls. Remember, one assumption that we make is that the horizontal motion, and this is not really an assumption, this is actually something we saw evidence for with the bullet dropped and fired, is that the horizontal motion and the vertical motion are independent. So we can separate our problem into two parts in order to figure out the solution. So first let's focus on the how far, and then later on I'll go into how fast. How far is a little bit simpler because it's distances. How fast, that's velocities. So like any problem, let's start by what are we given? So we know that the thing is 108 meters high. We know that that's the initial y position, and the final y position is 0. We also know that the initial x velocity is 3.6, and the initial y velocity, it's launched sideways, so that's 0. The acceleration in the y direction is 9.8, negative, and in the x direction it's 0, right? Okay, what we want to know is how far. How far, that's like our unknown, right? So our unknown is x, like the final position. So we really have an x problem here. X equals, well, the initial position, which is 0, plus the initial x velocity times the time. Nowhere do they give us the time. So if we don't know it, we need to go over here. Let's look at the y part. We know the height. Hey, this equation has time in it. We also know v0y is 0, so that term goes away, right? So all we got to do is find the time. So if we rearrange this, the time ends up looking like the square root of 2 times y minus y0 over a. And when you plug everything in and solve, you're going to get 4.695 seconds. I'm trying to keep a lot of sig figs so we don't make any rounding errors. And now we can go back, knowing the time, and find the x distance from the base of the cliff, like the x, position where it lands. So that's going to be 0 is where it started, times 3.6 meters per second, times the time, 4.695 seconds, and you get that it lands 16.9 meters from the base of the cliff. Awesome. Now, that's how far. How fast, that's a different question. So let's keep this in our minds, this 4.695 seconds, as we go to the next, part. All right, so we know, remember, that the time was 4.695 seconds, and now we want to find how fast. So we still have a lot of the same initial stuff, like the initial x is 3.6, the initial y is 0, and that's the time. That's actually all we need, because the velocity relationships, well, in the x one, remember I told you that because the x acceleration is 0, that's v x equals v0 x. So the final x velocity is going to be 3.6 meters per second. What does that mean? Final x velocity. Like when it hits, it's not moving in the x direction, right? When it hits, it's really going like that, right? When it lands, the water, it's got sideways motion and vertical motion when it lands. So what are we seeing here? This 3.6 is actually, it's the x component, right? Like Vx, the final x component. There's also going to be a final y component. And that we can find over here. So the final y component is going to be 0 plus negative 9.8 times time, I ran out of room, 695 seconds. So the final y velocity ends up being 46.0 meters per second. So this is 46. So then how do we find the actual velocity itself? We got to use Pythagorean theorem, right? So v is the square root of 3.6 squared plus 46 squared, and you end up getting that the velocity is 46.14 meters per second, just slightly larger than 46 meters per second. And that's how you would find the speed at the base of the cliff. If you wanted to find the angle, you could just use inverse tangent, right, and find the angle. Thanks for watching. I hope this was informative.